Okay, so we'll discuss some more problems on the energy and power signal. So then we will go to the next concept, which is basic operations on the signals. Okay, so x of t is given. So in this problem, the x of t which is given, which is equal to e power minus at into u of t, okay, where a is greater than 0. So x of t is given. So now we need to determine whether it is a energy signal or power signal. Determine the given signal is an energy signal or power signal. So now how to find out? So first we need to find the energy expression, then we have to apply, if it is not an energy signal, we have to apply the power signal expression to find out the power. So first we need to see whether it is having a finite energy, so then we can call it as an energy signal. So that we need to see first. So this is the expression for finding out the energy signal, that is energy of the signal, minus infinity to plus infinity x of t whole square into dt. Now substitute your x of t, which is e power minus at whole square. So u of t means, so u of t you can see, so you can substitute, that is 0 to infinity, because it is only positive sided signal, into dt. So now this we can write it as 0 to infinity e power minus 2at. So this we can write it as multiplication of this into dt. Now integrate this one, e power minus 2at divided by minus 2a. So limits we need to substitute 0 to infinity. So now if you substitute infinity, so e power minus infinity minus e power 0 divided by minus 2a. So e power minus infinity, it will be 0, and e power 0 is 1. So minus 1 divided by minus 2a. So which will equal to 1 by 2a. So which is greater than 0 and also which is less than infinity. Okay, it is a finite energy. So or we can say, so our condition is to, so not to get the infinite value, so it should be less than infinity, and it is a finite value. So then, so that's why the given signal is an energy signal. So is it understood? So how to find out the energy? So this kind of any exponential signal, so based on the value of a, so you will going to get the value. Even if I give e power minus 3t, you will going to give, so you will going to get 1 by 6. So similarly, so whatever the value of a, so we will going to get the value, corresponding value. Even if you replace e power, that is value of a, so then correspondingly you will get the value. Okay, so this is one kind of problem. So they will ask sometimes in the exam. This is exam problem only. Okay, so now we'll go to the next one. So is it understood? Any doubt in this one? So next one, so you take any ramp signal, that is x of t, which is equal to t into u of t. So this is generally it is varying linearly with respect to t. So since it is u of t 0 to, so infinity it will go. Okay, so this is t into u of t. Even you can take t square into u of t or t cube into u of t. These are all varying with respect to time linearly. Okay, so any signal of this type you can take. So we have to find out whether it is an energy signal or it is a power signal. Now first we need to find out, so whether it is an energy signal or not. Okay, x of t whole square into dt. So now minus infinity to plus infinity, so our given signal is, so multiplied with u of t, so we'll going to get 0 to infinity t square into dt. So if you integrate this one, t cube by 3 0 to infinity. Now if I substitute, so infinity here, it will going to give infinite value. So the given signal is not an energy signal. So but we need to find out what is the power. So let's see what we'll going to find out the power. So if it is finite power, then we can say it is a power signal. Okay, so limit t tends to infinity 1 over t, so minus t by 2 to plus t by 2 x of t magnitude square into dt. Okay, so here, so there we can't find out the periodicity, just we'll put it as it is. Limit t tends to infinity 1 over t minus t by 2 to plus t by 2. So x of t square is, so t square, so since minus t by 2, so it will not exist because it is u of t, it is minus, so 0 to t by 2 it will exist. If I take from negative to positive, it will exist from 0 to t by 2, t square into dt. Okay, so now if I substitute this one or integrate, so this one 0 to t by 2, so okay, we'll integrate this one. T tends to infinity 1 over t into, so if I integrate this one, t cube divided by 3, so we have to substitute 0 to t by 2. Okay, so if I substitute 0 to t by 2, limit t tends to infinity 1 over t into, so you can substitute this t by 2 whole cube divided by 3. Okay, so this is what the value. Now whenever t tends to infinity, put the values wherever it is t. Okay, so infinity, so since it is in the numerator, so this will give the value infinity. 1 over t it will give 0, and here it will be give, so t by 2, which is t in the numerator, it will give infinite value. So this signal, it is not an energy signal or nor power signal. It is neither energy or nor power signal, or power signal. So now even you can replace t with t square, t cube, whatever it is. So based on that, whatever integration, you will going to get infinite value. That is any ramp signal, so it is neither energy signal nor power signal. Okay, so is it understood, this one? Any doubt? So now try to do this one. X of t, which is equal to a into cos of omega naught t plus pi. So try to do this one. Find out whether it is an energy signal or power signal. So you can see, since it is a periodic signal, cosine signal with period which is equal to 2 pi by omega naught, so it is not an energy signal, definitely it is a power signal, because we have already discussed all periodic signals are the power signal, non-periodic signals are energy signals. So you can find out what is the average power of this signal. So how to find out average power? It is 1 over t minus t by 2 to plus t by 2 x square of t magnitude square into dt. So find out that this signal, this power, what is the power of this one? Use this expression to find out the average power of the periodic signal. Find the value of the power.
So a square by 2.
A square by 2. Okay, so since it is a less than infinity, so we will going to get the, so power as, so that is finite value of power. So it is a power signal with average power a square by 2. Okay, so this is how we are going to find out the power, and this is another important problem, this next one, it is from the exam problem only. So x of t signal is given here like this. It is from -5 to -4, and it is +4 to +5. So the amplitude value here it is 1. This is x of t is given, that is x of t which is equal to 5 minus t between 4 less than 5, so t less than or equal to 5, and similarly it is equal to 1 between 4 to 5, that is -4 to +4, and it is t plus 5 minus 5 less than or equal to t less than or equal to -4, and it is 0 otherwise. Okay, so this is the signal which is given, x of t. Find its energy. Since it is a non-periodic signal, so that's why we need to find the energy of this signal. Find its energy. Okay, even if this x of t expressions are not given, you have to find out. So because it is a ramp signal which is -5 to -4, so you can see here t plus 5. So if I put the value of t equal to -5, it is 0, and if I put the value of t equal to -4, so -4 plus 5, it is +1. So it is increasing ramp. Similarly, this expression can put the values of t, and then so it will be getting as decaying ramp. Okay, so between -4 to +4, it is the value 1. So even if the expressions are not given, you have to derive, so by using the sketch, the signal sketch. Okay, now find out the energy. So can put the expression -infinity to +infinity x of t square into dt. So now, so corresponding signal you can put from where to where the limit is there. So it is -5 to -4, that is t plus 5 whole square into dt, plus -4 to +4, it is 1, so 1 square into dt, plus so 4 to 5, that is t plus 5 minus t, 5 minus t whole square into dt. Okay, so only these limits you have to integrate, and you have to get the values. Try to get the value of this. What is the energy value? Just you can expand this using a plus b whole square and a minus b whole square, and you can get it the value. What is the value? Anybody got it? the value? Anybody got? Hello, Bharat, what's the value? Raghavendra,
Doing.
okay, can take this. So we'll do it -4 to -5 to -4 t square plus 10t plus 25 this into dt plus -4 to +4 it is 1 into dt plus 4 to 5 it is again 25 plus t square minus 10t into dt. Okay, now we'll go to the next step. So take this one and do it -5 to -4 t square plus 25 plus 10t. okay, and if I do it this one, it will give t into, that is t, so between -4 to +4, and then this one 4 to 5 t square plus 25 minus 10t into dt. So this, if you integrate this one, t cube by 3, so we need to substitute -5 minus 4 plus 25t, okay, plus 10t square by 2. Okay, -5 to -4 plus this one 4 minus of -4, you will going to get 4 minus of -4 plus here again t cube by 3, 4 to 5 plus 25t between 4 to 5 minus, it is minus 10 into t square by 2, 4 to 5. So now we can put the values: -4 whole cube minus of -5 whole cube divided by 3 plus 25 into -4 minus of -5, so plus 10 by 2 into, so t square, it is -4 square minus of -5 square. Okay, so this is over, so this is separate, don't confuse with this, this is separate. Okay, next I am writing the next step. So here it is 4 minus of -4, it will give plus 8, and then plus t cube by 3, which is equal to 1 by 3 into 5 cube minus 4 cube. Okay, again plus 25 into 5 minus 4 plus minus, here it is minus 10 by 2 minus 10 by 2 into, so t square, it is 5 square minus 4 square. So this is the value, and you can substitute and you can evaluate these values. So it is minus 64 and then minus, so again here it is minus 125, it is divided by 3 plus 25 into, so minus 4 and minus of -5, it is plus 5, so plus 5 minus 4 is plus 1, so it will give 1, and then so 10 by 2, let it be as it is. So minus 4 square is 60 plus 16 minus -5 square is 25, so minus into minus, it will become plus, it is 25. And similarly here plus 8 and then plus 1 by 3 into, so 5 cube is 125 minus 4 cube is 64, again plus 25 into 5 minus 4 it is plus 25, and then minus 10 by 2 into, so 5 square is 25 minus 4 square is 16. So this is what the values we are going to get. Then simplify this one. What is the value? Finally write it. So minus of minus is plus, so plus 125 minus 64, so it will come around 61 by 3. Okay, plus 25 plus, so here it is minus 9. Okay, minus 9 into 90 minus 90 by 2, that is what you will going to get, minus 90 by 2 plus 8 again plus, so here 125 minus 64 it is, so again 61 by 3 plus 25 minus, so here again 25 minus 16 is 9 minus 90 by 2. So now you can simplify this one. 25 plus 25 50, 58, so 58 plus 2 times 61 by 3, and then minus, final answer I will write in the next step. Okay, energy will be equal to, so 50 plus 61 by 3, that is 2 times 61 by 3 minus 2 times 90 by what is the value we got? Okay, so 2 times minus 90 by 2. Okay, so this will get cancel each other, so 3 into 50, 150 plus 2 into 61 minus 90 into 3, so this whole divided by 3. This will give 150 plus, so 122 minus 270 divided by 3. So this will give so much, 2 7 272 minus 2
by 3.
Okay, plus 8 we have left, I think, here. Okay, 25 plus 25 it is 50, so this 8 we have left, so that 8 also I need to take care. Here we can write this as 58, so 58 into 3, how much? 58 into 3, 174, so here it is 174. How much it is? So 6, 296 minus 270, which is 26 by 3. So this is the value of the energy for this particular problem. Okay, got it? So any doubt in this, how to integrate and get the value? So now this, till now this we have done the continuous time signals. Let us discuss one more problem on discrete time, one or two problems. So take this one, x of n, which is equal to u of n. So find out whether it is an energy signal or power signal. Okay, so for that, so write the expression for energy, which is limit n tends to infinity summation n equal to minus n2 plus n x of n magnitude square. Okay, so now find out, so the for this particular problem, put the x of n is u of n, which is limit n tends to infinity, okay, summation n equal to minus n2 plus n, So x of n is nothing but u of n square. So u of n is 1, so that is between 0 to n, so that is 1. So we have to substitute that. So limit n tends to infinity, so n equal to 0 to n, it will be 1, so that is 1 square. Okay, so now this will be given as limit n tends to infinity. So 1 between 0 to n, it will give n plus 1, so also that is n plus 1, 1 square is 1 only. So 0 to n, it is, if you summate all these ones, it will going to give n plus 1. Now if you substitute the n tends to infinity, so you will going to get the infinite value. So for this particular problem, energy will be infinite, so it is not an energy signal. Okay, so now we can find out the power of this one. Since it is not an energy signal, you can find the power. Okay, so try to find out the power. So what is the power expression? So it is limit n tends to infinity 1 over 2n plus 1 summation n equal to minus n2 plus n x of n square. Okay, so this will give limit n tends to infinity 1 over 2n plus 1 into, so now this summation varies from n equal to 0 to n, which is 1 square. So now this we can write it as limit n tends to infinity 1 over 2n plus 1 into, so this we can write it as n plus 1. So this will be limit n tends to infinity, so n plus 1 divided by 2n plus 1. So now I can take both numerator and denominator, so that n common. Okay, so if I take numerator and denominator n common, so I will going to get 1 over 1 plus n, and here if I take n common, it will get 2 plus 1 over n. Okay, now if I apply the n tends to infinity here, 1 over infinity is 0 and here 1 over infinity is 0. So both numerator and denominator will get, so this terms with 0 and left out with 1 over 2. So that's how we are going to find out the power. The power value, it is 1 by 2, which is less than infinity. So x of n equal to u of n, that whatever the signal, it is a power signal. Okay, it is a power signal. Okay, so is it understood? Any doubt? Okay, so now try to find out this one. X of n, which is equal to half power n into u of n. Find out this one, whether it is an energy signal or power signal. Is it an energy signal? Hello, anybody found out? Anybody found the solution? Bhavyashri, Maulya, Nivedita, Varun, Sandeep.
Yes, sir, understood.
So, what is the value which I gave the problem? Any value you got? Is it an energy or power signal? Rishabh, Gagan,
What I'm doing.
Sir, it is power signal.
how? Is it energy infinite? So use the expression. So the standard expressions are there, you need to use that. So summation n equal to minus infinity to plus infinity. So x of n magnitude square. Okay. So now, so here it is, so only from minus infinity to, so since u of n is there, you can have n equal to 0 to infinity. X of n square is half power n whole square. Okay, so this is what we will going to get. And so if you simplify this, n equal to 0 to infinity, so this we can write it as half square whole power n. So this will give, so summation n equal to 0 to infinity 1 by 4 power n. So now this standard expression, so that we know, summation n equal to 0 to infinity alpha power n, so which is equal to 1 over 1 minus alpha when alpha is less than 1. Now we can see in our problem alpha is 1 by 4, which is nothing but less than 1. Okay, so we can write this summation as 1 over 1 minus alpha, alpha is 1 by 4, so which is equal to, so 4 by 3. So this will give finite energy which is less than infinity, so that's why it is an energy signal. Understood this one, or any doubt in this? Hello. So
Understood, sir.
don't confuse with the expression, because earlier I used limit n tends to infinity summation n equal to minus n2 plus n x of n square, right? The same expression only I put n tends to infinity here only, minus n equal to minus infinity to plus infinity. Just I substituted in this expression n tends to infinity, so that's why it is minus infinity to plus infinity I have directly written. But earlier whatever the expression is there, the same expression, so modified version is this one. Okay, so any doubt? Understood this one? So you need to use this standard expression which I wrote earlier also 4 standard expressions are there. So when alpha is less than 1, you can use that and you can obtain the values. Okay. Okay, so take this one and try to do this one. Definitely there is a one problem based on this energy and power signals, so I need to practice more. X of n, so which is equal to 2 into e power j 3 into n. So take this one and find out whether it is an energy signal or power signal. Try to find out, use these expressions and do it. Limit n tends to infinity, summation n equal to minus n2 plus n, so x of n square, so which is equal to so limit n tends to infinity, summation n equal to minus n2 plus n, so now 2 into e power j 3n whole square. Okay, so now you can take out this 2 square, which is 4 outside. Limit n tends to infinity, summation n equal to minus n2 plus n e power j 3n whole square. So now this we can write it as directly 6n e power, so e power j 6n. Now if you take, so this exponential signal, the magnitude of this one is nothing but 1. So magnitude is always 1 into e power something like that it will come. So the magnitude is always, so it will be like j phi n or j something like this. Okay, so the magnitude of this exponential signal, so it will be always 1. So now we can replace this one as 1. Okay, 4 limit n tends to infinity minus n to n, summation n equal to minus n to n, this is 1. Okay, now if you put, so this summation if I evaluate, you will going to get so 2n plus 1. So this complete summation including the sample at 0, it will be, so minus n to minus 1 it is n and 1 to n it is n, so that is 2n plus 0th sample, it is the summation is 2n plus 1. Now if I put n tends to infinity here, it will go to infinity. So energy will be infinity, so it is not an energy signal. Okay, it is not an energy signal. Now find out power, whether it is possible to get the power of this one. So then we'll see, will it be a power signal. Okay, so take this one and try to get the value. So summation n equal to minus n2 plus n x of n whole square, so which is equal to, so limit n tends to infinity 1 over 2n plus 1 summation n equal to minus n2 plus n, so 2 into e power j 3n, so this is square. So take this 4 out, limit n tends to infinity 1 over 2n plus 1 summation n equal to minus n2 plus 1, this is again e power 6n, the magnitude is 1. So now evaluate this one, so we will going to get 2n plus 1 into 2n plus 1. Okay, So now this will 2n plus 1 will get cancel each other, so we will going to get the power value as 4, so which is less than infinity. So now the given signal is a power signal. Okay, so it is a power signal. Okay, understood? Any doubt in this? So how to get the even energy, find out the energy or power signal in discrete case. Okay,
Sir, I have a doubt, sir.
yeah, ask. What is that?
Sir, in the previous problem, you considered that n is equal to minus infinity to infinity, no, sir?
Here,
1 by 2 power n into u of n.
here, yeah.
Sir, in what all cases can we like consider like that condition, sir?
Which one in finding out?
Uh, n is equal to minus infinity to infinity, sir.
Okay, here.
The above step.
Okay,
Yes, sir.
okay.
Sir, in this particular problem, we have taken it like this, no, sir.
So this expression itself you can take and you can substitute that also. So this is a
Okay, sir.
standard expression, right?
Yes, sir.
So even you can substitute this half power n minus n2 plus n. So this half power whole power n, whatever you will going to get from minus n to plus n, you will going to get. Again, if you put n tends to infinity, it will go to minus infinity to plus infinity only, na? What is actually your doubt?
Yes, sir. Like if we considered it from minus n to n, right, sir?
Okay.
Like in this problem also we can consider it to be like minus infinity to infinity. No, sir. Will that be wrong, sir?
Here, finding out the energy for this
Yes,
particular
sir.
for this particular problem, like here whatever we found out,
Yes, sir. Any other problems
that half
in the
power,
in the similar way?
yeah, that you can do it. So energy from
Yes.
minus infinity to plus infinity can be able to consider for other problems also.
Yes, yes, sir. Or
Even
is it like applicable to specific problems only, sir?
no, you can take that summation minus infinity to plus infinity only energy, but based on the
Okay, sir.
expression from where to where the limit it is there, so then you can put that.
Okay,
So
sir.
that is based on the again problem how it is given.
Okay, sir.
Okay, so that you need to take care. So whenever you are finding out the energy, you can take this expression minus infinity to plus infinity, but where the limits
Okay,
are
sir.
given for that particular problem, so that you have to so specify that you have to see from where to where we have to take, like that.
Okay, sir.
So even earlier also I have done one problem taking minus infinity to
Yes,
plus
sir.
infinity, but the limits are, so that is for like 10 minus n we have got from 5 to 10, n ranges from 5 to 10. Okay, so that
Yes,
earlier
sir.
problem we have done, right? And it is n
Yes, sir.
from
Yes,
0 to 4, something like that. So
yes,
here
sir.
also we are considering minus infinity to plus infinity only, but where actually the n varies. So based
Yes, sir.
on that limits you have to take.
Okay, sir.
Okay. Okay. So even you can take this expression. So whenever n tends to infinity, it will become the same expression. Or you can take and you can substitute this half power n into u of n here only. But we don't have any standard expression to evaluate that. Is it not?
Yes,
So,
sir.
so we need to convert that one into standard expressions which we know already the results. So then we can evaluate that
Okay, sir.
whatever the energy. Okay. Okay. So these are about the energy and power problems, and now we'll move on to the basic operations on these signals. Okay. So here, so there are two actual basic operations, that is operations performed on the dependent variable and operations performed on the independent variable. Okay, operations on dependent variable and operations on independent variable. Okay, so but most of the cases, so in the examination point of view, it is asked only for the independent variable. So I'll discuss this only. So dependent variable, it is just like a scaling, that is amplitude or multiplication of two signals or addition of two signal, integrator, differentiator, those will be there. So that is not a difficult concept to understand. So here independent variable is very important. Okay, so if we have y of t which is equal to x of t, something like that. So now this is a dependent, so the function, and this is independent function. Now what are the operations which will perform on the independent variable, that is x of t? So where the t is, so this is independent signal. So the operations which we perform on this time variable, it will be called it as, so operations on independent variable. Now what are all those operations are there? So basically, so there are three operations, that is time shifting. Okay, time shifting, and then time scaling. Okay, and then reflection, or time reflection we can call it as. Okay, time shifting, time scaling, and reflection. Now if we have, so the signal, what is time shifting? If we have the signal like, so y of t, which is nothing but something like, so u of t, let us take that is u of t, that is, so the unit step function. Okay, unit step function u of t. So now we know that u of t is always 1, so from 0 to infinity. Now what is meant by time shifting? Now if I so shift this signal by an amount, that is u of t minus a. Okay, so now this a may be any value. Okay, so it is t minus a means it is right shifted signal. Okay, so that means, so somewhere here the value of a will be there from 0 to the value at 0, t equal to 0 to till the value of a, the signal is right shifted. So that is what t minus a. So that is time shifting. The time of the signal is shifted by an amount of the value a. Okay, similarly if I put t plus a, okay, instead of t minus a, if I give t plus a, it will shift to the negative side. Okay, so this is a positive side and this is a negative side. Okay, so now if I put the t plus a, it will going to shift the signal by a, so amount a in the negative side. So that is, so this will be the value of the t minus a, where it is shifted to the value a in the negative side. Okay, so this is what time shifting, either positive shift or negative shift. So t minus a or t plus a. Okay, so this is what time shifting. And you can take any signal, so any type of signal you can shift that. Okay, so let us take another an example. So where we have the triangular function between -1 to +1. Okay, so now this is your x of t. Now I need to shift this signal by an amount of t minus 2. Okay, and also another, so shift which I want to do, t plus 3. Now how to do it? So now we need to shift the signal by an amount 2. Okay, so now here it is -1, 0 and then 1. So now if I shift the signal by an amount 2, which is a right shift value, so we will going to get, so from -1 to, So that is the value which is minus 1, it is shifted to plus 1 by an amount value 2, because minus 1 and 0 and 1. So the 2 value I am going to shift it as a right, right shift. So now it will going to give plus 1, plus 2 and plus 3. So the shifted signal, it is between 1 to 3. So for this particular case. Similarly, if I shift in the negative side, so how much value I need to shift? It is 3 value. It is 1, 2 and 3. So it will start from minus 2. Okay, so again it is minus 3 in between and then minus 4. So this is what x of t plus 3. So where the value of the signal, it is shifted by an amount 3 in the negative side. Okay, so is it understood? So the time shifting, any doubt? Okay, so now this is what time shifting. Now we will go to the time scaling. Okay, so time scaling. What is time scaling? Again, so if we have the signal x of t, okay, now let us take this itself, x of t. Now between minus, so something like minus t to plus t, or in general we can take, okay, minus 1 to plus 1 itself. Now this is x of t. Now time scaling means, so either we have to scale this, so this the value a, okay, so this is what we are scaling the time scale. Okay, so that is, so based on the value of a, whether the signal is expanded or so the compressed version, we can able to get it. So now here the value of a is, so if it is like, so if it is greater than 0, that is always it should be greater than 0, then it is a compressed version. So then if it is less than 0, then it will give a reflection, so that we will see. So for this case, assume a equal to greater than 0. So then x of at, so whatever we will going to get, based on the value of a, so it will going to compress. Whenever x of at if we return, so this signal, it is divided by the value a we need to do. So since the time value it is divided by a, so compared to the original signal, it is a compressed version. Okay, so that is what, so one of the, so the time scaling operation, it is a compressed version. Okay, so now similarly, if I take x of t by a, okay, so now if I divide the time scale by the value a, so then this, the resultant signal will be an expanded version. Okay, okay, so it is an expanded version. So that whatever earlier minus t is there, now we have to multiply that by the value a. So it is an expanded version. So there are two kind of scaling, one is compressed one and another one is expanded version. So if I put, so the value of a to t, x of at if I write, so then in the signal you have to divide that time scale by a, and in the similar way x of t by a, if it is given, then you have to multiply that value of a to the time scale. So then it will give the expanded version and this will give the compressed version. Okay, so this is what the time scaling. So now if I do for this only, so if I take the same example and if I do, okay, so it is between minus 1 to plus 1 x of t. Now if I do y1 of t which is equal to x of 2t and y2 of t which is equal to x of t by 2. So now what is y1 of t we will going to get? It is 1 by 2, 1 by 2. Okay, so this we have to divide it by 2, which is equal to minus 1 by 2, and this is plus 1 by 2. This is y1 of t. And similarly y2 of t, so we will going to get, so if you have to multiply by 2, so minus 2 to plus 2 we will going to get. Okay, so that is minus 1 into 2, we will going to get minus 2 to plus 2. Like this, it is a compressed version because it is minus 0.5 to plus 0.5, 1 by 2, 1 by 2. So we can compare with the original signal, it is in a compressed version, and compared to original signal, in this case it is an expanded version. Okay, so this is what the time scaling. And final one, it is a time reflection. Okay, so that is an inversion of or mirror image around the vertical axis. That is, if we have the x of, so something like this. So for the better understanding of the reflection, we'll take the x of t slightly different signal, which is like this. Okay, which is from 0 to 1, let us take. So this is x of t and this one is 0.5, let us take. Now if I take the x of t like this, now what is meant by reflection? Reflection is the mirror image of the signal around this vertical axis. That is, so if I want x of minus t, so the mirror image we need to take. That is, around this vertical axis we need to flip the signal to its mirror image. So then we will get that the reflection. So this is x of t and this is x of minus t. Wherever the value of t is there, put minus t. So then you will going to get the reflection. So let us take here, so it is 0 is there, if I put t equal to 0, 0. And t is 0.5, if I put minus 0.5, it will give minus 0.5. And similarly here 1 is there, if I put minus 1, it will give, so minus 1. So that is what x of minus t, that is a reflection of the signal around this vertical axis. Okay, so these are all very important operations: time scaling, time shifting, and reflection. Now, so there is a precedence rule. Which one need to do the operation first while given all the operations in a single signal? Okay, so that rule is precedence rule. So that is, first one we need to always do the time shifting. Okay, so the first one we need to always do the time shifting. So then we have to do the second one, time scaling. Okay, so then we have to do the reflection time, that is reflection. Okay, so then this you need to follow while, if the signal having all these three operations in a single signal, you have to follow this rule. First we need to do the time shifting, next time scaling, then we have to do the reflection. Okay, so now we'll take some problems. So based on these basic operations, we can later we'll see others problems based on these different kinds. Okay, so now we can do this one. Take this one, try to do this one. Y of t, so sketch the signal, so y of t, which is equal to x of t plus x of 2 minus t. Okay, so this is, we need to add these two signal, and then, so first you need to do the operation and then you need to add the signal. So x of t is given it as like this, minus 1 to plus 1 is like this, then 0 to 1 it is 1, and 0 to 1 to 2 it is the value 2. So now this is a x of t is given. Now we need to add this x of t plus x of 2 minus t. Okay, so now here, so for this particular this one signal, x of 2 minus t, so this also can be written as x of minus t plus 2. Okay, so in this particular case there are two operations involved. So what are the operations? First one is time shifting, then it is a reflection. Okay, So it is shifting operation, then it is reflection. Okay, so as per our rule, first we need to do the shifting. So first we will do the shifting operation, that is x of t plus 2. So t plus 2 means in the negative side we need to move, so the value amount 2, that is if I move 2, that is amount of 2 in the negative side, it will go to minus 3. So then the signal between minus 3 to minus 2, it will be a ramp, and then so minus 2 to 1, it will be the amplitude value 1. Okay, then from 1 to 2 we will going to get so the magnitude value 2, and then it will be coming to 0. So now you can see the signal, it is shifted so by amount of 2. So wherever 2 is there, and if we shift the 2 values, it will become 0. So now this is your x of t plus 2. Now again we have to do the reflection of this one. Now if I take the reflection x of minus t plus 2, so we will going to get like this. So this is what the reflection of the signal. So this is minus 3 to minus 2, and then minus 2 to 1, and 0 to, that is plus 1 to 0. So whatever the negative values are there, it will going to reflect and it will give the positive values. This is what x of minus t plus 2. Okay, so is it understood now? So now this is x of minus t plus 2. Now we have to add this x of t to this one. Okay, so write down the x of t minus 2 below this one, minus t plus 2 or so 2 minus t. So it is given like this, minus 3, this is minus 2, and this is plus 1, and this is 0. Okay, 0 1 2 3. So now you can see, so whenever we add these two signals, okay, whenever we add these two signals, now we will go from so 1 by 1. Now from minus 1 to 0, so there is no signal here, so whatever the same signal is there, it will appear. So addition of these minus 1 to 0, so here it is 0 and it is ramp, so it will be same as that one, minus 1 to 0, it will be the same ramp. Now here at 0 it will be 1, and here it is at 0 it is 2. Now 0 to 1 it is 2, and 0 to 1 it is 1. So 1 plus 2, it will be given it as 3. Okay, 0 to 1 it will be 3. Okay, 0 to 1, so this will be the value 3. So now from 1 to 2 it is 2, and here 1 to 2 it is so 1. Okay, so 1 plus 2 again 3. So from 1 to 2 it will be the value 3, it will be as it is remain. Now you can see, so from 2 to 3 it will be 0, and here 2 to 3 it is a decaying ramp. So now from 2 to 3 you will going to get the decaying ramp. Okay, so this is what the so x of t plus x of 2 minus t, which is nothing but y of t. Okay, so I'll write once more here the how the signal came, minus 1, and it will go to 3. Okay, so this is 3, and it is staying till, so this is 0, and this is 1, and this is 2, and then decaying ramp, so from 2 to 3. So this is what you will going to get y of t. Is it understood?
Sir, 1 second, last steps.
Last step, it is 2 to 3, it is a decaying ramp, right? So now here 2 to 3 there is a no value, 0. 0 plus,
No, from minus 1, sir.
okay, from minus 1 to 0 it is a so the growing ramp, right? Minus 1 to 0 growing ramp. Here minus 1 to 0 there is nothing is there, it is 0. 0 plus anything is there, whatever it is there, the same thing it will come, minus 1 to 0.
The actual signal will not be the present. So when x of t plus 2 is not there, when x of t is there, it should not come, sir. It should become 0, no, sir.
What?
Minus 1 to 1.
What?
Minus 1 to 1 will become 0, no, sir. When x of t plus 2 will not be there at the output side.
No, x of minus t plus 2, it is 0 here. Minus 1 to 0 we have to take, right?
Yes, sir.
See here, it is not multiplication, it is addition. If it is multiplication, it is 0. 0 into whatever it is 0. Here it is not multiplication, it is addition. Addition means whatever value here it is there. Say for example at minus 0.5, it will be having some 0.5. 0.5 plus 0, what is there? 0.5. 0 plus 0, it is 0. And here it is 1 plus. So here it is at 0. 1 plus 0, it is 1. Is it not?
Sir, got it.
Okay. Still any doubt? Hello? Anybody still any doubt? Okay. So now try to do this one. So x of t is given like this. Okay, x of t is given like this. So now we need to find out y of t, which is equal to x of 3t plus 2. So do it. So from where to where you will going to get this one? This is 0. So from where it will going to start?
Minus 3.
So minus 3 to minus 1. So this is actually t plus 2, not y of t completely. It is x of t plus 2, right? So now if you scale by the value 3, you will going to get x of, that is y of t equal to x of 3t plus 2. So now if you scale this one, you will going to get minus 1 by 3, minus 2 by 3, and then minus 3 by 3. So that's how we will going to get the signal. So this will between minus 1 to minus 1 by 3. Okay. So this amplitude value will be 1. Okay. So it will exist between minus 1 to minus 1 by 3. Now, so only if I take something like this one, y1 of t. So now we have find out y1 of t. Now y2 of t, I will just take x of 3t. Okay. So find out y2 of t, which is x of 3t. So this is whatever x of t is there, just divide it by 1 by 3. That is minus 1 by 3 and plus 1 by 3. Okay. So this is y2 of t, which is nothing but x of 3t. Okay. Now I want the y of t will be addition of y1 of t plus y2 of t. So solve this one. Try to solve this addition of these two signals. What you will get? So this y1 of t is between minus 1 to minus 1 by 3, and y2 of t is starting from minus 1 by 3 to plus 1 by 3. So how we are going to get if I add these two signals? You are going to get like this. That is minus 1 minus 1 by minus 2 by 3 minus 1 by 3 0 plus 1 by 3. So this is what your y of t. So if I add these two, y1 of t plus y2 of t, we will going to get, the amplitude value is 1, we will going to get minus 1 2 plus 1 by 3. So got it? Is it understood? Any doubt in this?
Understood.
Okay, so now one more type of problem they will ask, that is they will give the expression and they have to like they will tell to sketch the signal, that is in terms of unit step function, that is something like this. Okay, something like this. That is sketch the signal x of t, which is equal to 3 into u of t plus 3 minus u of t plus 3 into u of t minus 3. Okay, so this kind of problems. So they will give like in terms of unit step function and try to sketch this x of t. So first we need to see, so what are the operations individually. So let us take this one as v1 of t and this one as v2 of t and then this one as v3 of t. Okay, then finally we will going to add these signals, we will going to get x of t. So now this one, so 0 to infinity, you will going to get this u of t. So this we know unit step function, it is vary from 0 to infinity in the positive side. Okay, that is, so 1 for t greater than 0 and it is 0 t less than 0. So that is what the unit step function. So 1 for t greater than 0 and 0 for t less than 0. So actually there is a discontinuity here at exactly t equal to 0. So we have to tell t greater than 0 only. Okay. So this is what unit step function. Now we need to perform the operations on this one. Okay. Now first, so try to find out what is u of t plus 3. So u of t plus 3 means it is shifted negative side by the amount 3. So this is u of t plus 3 and here it is the scaling. So it is scaling on dependent variable. So not the time scaling, it is the amplitude scaling. So amplitude scaling means, so this is the value 1. If I multiply the amplitude scaling factor 3, so this will become minus 3 to infinity, the amplitude value which is 3. Okay. So this is your 3 into u of t plus 3. So that is nothing but v1 of t. So this is where v1 of t. Okay. So similarly v2 of t, it is nothing but a reflection, that is, so whatever negative side. So this is u of t. Okay. So this is a reflection on the x axis, that is horizontal axis, not vertical axis. Vertical axis is on independent variable, here it is on the horizontal axis which is the time axis. So now this is u of t, minus u of t means it is a negative value of the amplitude. So this is 1. Now here if I multiply this one minus, you will going to get like this. This is minus 1. So this is your v2 of t, which is nothing but minus u of t. Okay. So now similarly, so v3 of t will going to get, so it is a similar like it is negative shifted and this one is positive shifted. Okay, so positive shifted means plus 3 to infinity. So this is nothing but, so the amplitude again it is scaled version, the amplitude version it is 3. So this is nothing but 3 into u of t minus 3. Now we need to, all these three signal we have to take and we have to add it to get the x of t. Okay, so now take all these three signals and write it in a, so one axis, so that we will going to add these three signal, that is v1 of t, it is minus 3 to infinity, the amplitude value is 3, then v2 of t which is minus 1. Okay, then v3 of t which is again plus 3 to minus infinity with the value 3. Now you can see our signal is starting from minus 3, because so one of the signal it is minus 3, we will see the resultant will be, so from minus 3 what is the value. Okay, so now from minus 3 you sketch the final x of t, so addition of all these signals. Now you can see up to 0 there is no signal, so minus 3 to 0 whatever the value it is there, the value amplitude it will follow. Okay, minus 3 to 0, so the amplitude will be 3. Now you can see at 0, so this will be minus 1 and this will be 0 and this will be plus 3. So plus 3 and minus 1 we will going to get plus 2. Okay, so at 0 it will give plus 2, and till what is the value, till the value of 3. Okay, so till the value of 3 it is 3 minus 1, so till the value of 3 it is the amplitude value 2. Okay, now at 3, so here it is becoming 3 and then this one is 3, 3 plus 3 is 6, again 6 minus 1 it is 5. So from 3 it is the value of amplitude which is 5 and it is go on till infinity. Okay, so this is what you will going to get the x of t. Is it understood? Any doubt? So 3 minus 2 and then at 3 it will going to give 5. Is it understood this one? Any doubt? Hello, anybody, any doubt?
No doubt, sir.
So by taking unit step, so you need to operate some, that whatever the operations on this signal, and like this we have to sketch. So these are also one of the type of the problem. Okay, so another type is, so they will give the signal, so like this resultant signal we have to write the expression. So that is whatever we did now, it is a reverse case of that. Okay, so that type of one problem we will going to see. Okay, okay, so take this one. Okay, express x of t in terms of u of t. Okay, so x of t is given like this, so it is 1 here and then 2 here, then 3 here, then 4 here. Okay, so here it is 1 2 3 and then 4. So like this is the x of t which is given. So now we need to express this in terms of u of t. Okay, now how to do this one? So first we need to see the amplitude from where to where the 1 it is. So following, okay, it is from 1 to 4. Okay, so now 1 to 4 we have to only express the u of t. So for that, what I'll do, I'll take u of t. You can see, so u of t is till infinity, it will go on. So now I'll take the another signal which is shifted by 4 units, that is u of t minus 4. Okay, so now if I subtract this u of t minus 4 from u of t, you will going to get the signal up to 4 like this. Okay, so because at 4 it is plus 1 and here also it is plus 1, if I subtract this signal from this signal, so 1 minus 1 it will go to 0, that is u of t minus u of t minus 4. If I get, I will get the signal from 0 to 4. So that is what from first step of the signal. Okay, so in the second step what I need to get, I need to get from only 1 to 2 the amplitude 2. Okay, so only 1 to 2 means, so I need to get the signal only 1 to 2, that is sorry, so the signal from only 1 to 2 I need to get. So 1 to 2, if I want the signal with the amplitude 1, what I need to do? So I need to get, so again from the unit step function, so similar like I have to subtract 2 signals and I have to get the signal which is 1 to 2. So this step. Okay, so now what I need to do, so 1 to 2 if I want to get u of t minus 1, so that is your this signal. Okay, so then I have to get, so u of t minus 2 also. So t minus 2 means, so you will going to get from 2. So this is 1 and this is 2. Again now if I subtract from this to this, you will going to get, so this signal, the second signal which is from 1 to 2. Okay, so again if I add those two signals, you will going to get, so the amplitude value from 1 to 2 it will be 2 and then it will decrease and it will give 4. So similar like, so we need to get from 2 to 3 the amplitude value, so 3. So like that we need to go on doing the operations, so then we will going to get the resultant. So or else, so one more possibility is, instead of doing like this, so one more possibility is you just do all the addition from, like this is u of t, okay, and then u of t minus 1, like u of t minus 1, this is u of t minus 1, and similarly u of t minus 2. Okay, so then u of t minus 3. Okay, so then u of t minus 4, like that you can add. So what you will going to get, so if I add all these things, u of t from 0 to 1 it is the value 1. Again at 1 what will happen, 1 plus 1 you will going to get 2. Again at 3 what will happen, so 1 plus 1 plus 1 you will going to get 3. And at 4 what will happen, so again at 4, so you will going to get 1 plus 1 plus 1 plus 1. So all these 4 signal added together you will going to get, so the amplitude value 4 between 3 to 4. Okay, so then in order to bring this down, so we need to add the signal such a way that it will go to 0, that is, so amplitude should be 4 times and it should come to 0, that is 4 times the negation of that unit step function. Okay, so first we'll add these signals u of t plus u of t minus 1, u of t minus 2, u of t minus 3 and u of t minus 4. Okay, so t minus 4 is, so till this value it will going to get, so the value 4. Okay, so that is u of t plus u of t minus 1 plus u of t minus 2 plus u of t minus 3 plus u of t minus 4. What you will going to get? So you will going to get like this. So that is from 0, 1, 2, 3, 4. At 4 it will be constant. So because all the addition value it will go on keeping, so 4 amplitude. Now I need to bring it down at value 4 to 0. What I need to do? So I need to add minus 4 times u of t, t minus 4, because it should start from 4, t minus 4. If I do like this, so minus 4 and this amplitude it will cancel each other and it will going to give 4. So I need to add minus 4 into t of, that is u of t minus 4. So this is your, so the expression x of t. Is it understood? Any doubt in this? Hello. So this is one of the important problem, it will ask this kind of problems. So I need to add all the amplitudes and at 4 I need to bring it down. So that's why at 4 I am giving the amplitude scaling 4 and then negate it. So I will going to get 0. Okay, is it understood? Hello, anybody, any doubt? Manoj?
No, sir. Understood.
Okay. Gagan, Rishabh?
No, sir. Understood, sir.
Understood, sir.
Harini?
Understood, sir.
Okay, so these kind of problems we'll do still more in tomorrow's class. So we'll stop here. Okay.